It's been just over a month since this book's release, and I'm so excited about it, but here's problem 386 to do. So in order for us to solve this particular integral, we're going to use King's rule right here, which tells us this expression. So first, let's just go ahead and make this integral I for safety reasons, and then let's go ahead and say that another integral I is also equal to the integral from 0 to 1, and then we're going to implement King's rule. So we have every value of x is now going to have 0 plus 1 minus x, all over, and then we have e to the 0 plus 1 minus x plus e to the 1 minus 0 plus 1 minus x, all with respect to x. Okay, so let's go ahead and start simplifying some stuff. On the top, it looks like we just have a 1 minus x right on. On the bottom, we have an e to the 1 minus x. Okay, plus, and then let's talk about this one. If we distribute the negative, we're gonna have negative 1, which is gonna cancel out with this one right here. Okay, and then we have the negative times negative x, so that's gonna be positive x dx. So let's go ahead and add those together. So 2I will equal to the integral from 0 to 1, and because they have common denominators, we're just gonna add the numerators together. So x plus 1 minus x is simply just 1 over e to the 1 minus x plus e to the x dx. And now let's go ahead and start simplifying this by multiplying the top and bottom by e to the x. So we're gonna have 2I equals integral from 0 to 1. On the top, we have e to the x over, and if we distribute this e to the x to this one, watch what's gonna happen. This is e to the 1 times e to the negative x, and then we're going to multiply by e to the x, so we have e to the x plus, and then e to the x times e to the x is going to be e to the 2x with respect to x, giving us an integral 0 to 1 e to the x over e plus e to the 2x with respect to x. So we're going to make u equal to e to the x. Du is going to equal to e to the x dx, and that's going to be helpful because this is right here. That's amazing. And then our parameters are actually gonna stay the same. No, they're not. They're actually gonna be a little different. When x is equal to 0, u is gonna equal to e to the 0, which is just 1. So x is equal to 0, u is equal to 1, and then when x is equal to 1, u is gonna equal to e. So now our integral is gonna turn into 2I is equal to the integral from 1 to e of 1 over e plus u squared with respect to u. 2I is equal to 1 over root e tan inverse, or arctan if you want to see it that way, over 1 over root e, and then from 1 to e. So 2I is equal to 1 over root e tan inverse of e over root e minus 1 over root e tan inverse of 1 over root e. The original integral I is going to equal to, let's go ahead and factor this out. It's going to be 2 root e, and then we're going to put a parentheses, tan inverse is e over root e minus tan inverse of 1 over root e, and then we are done.